Welcome to the JPS Product Briefing Webcast. My name is Carol Hollingsworth. I'm the Vice President of Sales at JPS, and as always, I'm with Iggy Brigado, Senior Solutions Engineer at JPS. In this episode, we will continue our discussion on the Z-Series controller, but specifically the seamless distributed connectivity feature set called UNITY. For more complex management of multiple communications resources over a wide area environment, the Z-Series controller and its UNITY feature set can facilitate patching, remote control, and management of resources and gateways from a single platform more easily than ever before. We'll discuss the efficiency of UNITY Talkpaths where voice communications are shuttled over Unicast network links from distributed resources. We'll also touch on the messaging that takes place in the background, allowing configuration, control, and coordination of distributed Z-Series gateways in a tight, systematic method. And finally, we'll look at another UNITY feature called Discovery Mode. This feature allows the simplified federation of subordinate Z-Series gateways into a tightly integrated wide area system. When a Z-Series controller is temporarily placed into the Discovery Mode, it can now authenticate any remote Z-Series gateway that wants to be part of a system. Once the binding is completed, Discovery Mode can be turned off for security purposes, but the remote gateways are persistently bonded with the parent Z-Series controller and other JPS communication devices that comprise the wide area system. We'll have more JPS product briefing webcasts in the next coming weeks to introduce other unique features of the Z-Series controller and the UNITY feature set. At this time, let me introduce Iggy Brigado again. Iggy, would you like to present this awesome new feature that we have with UNITY?
Yeah, Carol. Yeah, I think you pretty much said it all. You definitely summarized what we're going to talk about. But yeah, this is pretty exciting. Unity's something we just recently introduced. It's really a subset of features, some of which have been in place for a number of months. But Unity is kind of going to be an evolutionary type of a feature set, and you're going to see newer and more unique Unity feature sets coming into the future. So it's pretty exciting. It's hard to believe that we can improve this, but it's pretty unique. So really, as you mentioned, Carol, there's a few things I want to talk about, and I want to illustrate that for our viewers. But really, we're going to stick with Unity right now. But in future webcasts, we're also going to dive a little bit deeper into Unity in terms of how it looks in terms of an operator and how we engage a controller using a browser-based user interface. So let's get started. Kind of do a very simple review of what we talked about in our last episode. And we talked about the implementation of Unicast and Multicast links, which are very common in JPS products since 1999-2000, when we first introduced our form of RoIP, which is a very radio-centric form of voice transport over networks. And as you can tell from the list of products that we have on the right, you'll notice in the Z-Series product line, support only Unicast. And you're going to see why we do that. Probably, in my opinion, one of the main reasons we support only Unicast in the Z-Series product line as opposed to including Multicast is because a lot of the agencies we've been working with, because of network policies, don't allow multicast. So we're really kind of focusing on the Unicast method of transporting voice communications by creating these definitive peer-to-peer links between devices, especially when we're dealing with distributed resources that we see illustrated here. And one of the nice things about Unicast or Multicast is we can actually log into these devices, reprovision those devices. Again, as we mentioned last episode, that sometimes can be problematic. It could cause errors and be difficult to do. What we want to do is really kind of focus on Unicast communications. And really the feature here is, in terms of Unity, is the controller, in this case, the Z-Series controller. We liken that again to a wide area system builder, as well as a management hub, which you, Carol, mentioned that we can control, coordinate communications from our remote systems or devices out in the field. That management allows us to log into a single platform from a single location multiple users can do this as well using secure login and control, again, coordinate and configure the system from a single platform. And what really, to me, one of the big takeaways is you can create this immediate and dynamic linking of remote resources anywhere on the network. We can create this unification of resources by way of a controller, and specifically Unity, we can create a very seamless wide area system. You mentioned earlier, Carol, was discovery mode, and we'll kind of focus that at the end of the presentation. Again, really kind of this simplified unification of these gateways, remote gateways, into a system. And so that introduces us to the Unity feature set, which we introduced last week, and we call that the Seamless Distributed Connectivity feature set. And so if you look at a distributed architecture here with many gateways that include our latest Z-Series products, as well as some of our legacy gateways like an ACU-M, and naturally Z-Series products, the ACU-Z1, as well as the RSP-Z2 dual channel gateway. And there's many different ways of distributing voice communications, telephony communications using JPS standard RoIP. And because all our products have incorporated JPS standard RoIP, we can create definitive RoIP links. And in this case, and illustrated here, we've got these Unicast links delivering land mobile radio communications, push-to-talk of a cellular, or telephony in the form of SIP. We can create these definitive RoIP peer-to-peer links back to the controller, where we can then distribute or redistribute that audio back to other remote devices. So we like Unicast because it's a very strong bond, peer-to-peer, very simple definitive link. This is how we pass our communications, telephony, or land mobile radios between devices over the network. And as you know, a lot of our legacy devices support multicast. A lot of networks won't support multicast. Agencies, because of network policies, will not allow multicast on their networks. And just to simplify in terms of managing these RoIP links, we like using Unicast. All right, so that in mind, we can create these, again, very definitive peer-to-peer links. Another feature in Unity is what we call Talkpaths, and we talked a little bit about Talkpaths in our last episode. We're going to really kind of dive deep into the definition of a Unity Talkpath. And as you can see in this illustration, we can create these Talkpaths from the remote resources back to the controller for redistribution or management. In Unity is defined by what we call the routing policy. Again, we'll look at that a little bit later as well. One of the most important resources in our catalog in terms of Z-Series gateways, again, is the RSP-Z2. We've talked a lot about this RSP-Z2. As you can see, the user interface on the left, again, it's all browser-based. We're logging into the hardware. We're not logging into servers. And we can create these different net configurations. So you can see them listed down on the bottom. We can create a very simple cross-connection. We can create a cross-connect with a network backhaul using various forms of digital backhaul. That could include push-to-talk of cellular, a JPS bridge, JPS RoIP, SIP, RTP. As you can see in this diagram, we have two donor radios associated to the RSP-Z2 with radio interface cables, and they're also being represented by icons or tiles in the user interface, as you can see on the top. We can then independently pass that information to a digital backhaul. In this case, we're going to use JPS RoIP as an example. I want to create a distributed solution. I can take these two radios, for instance, that might be on the west side of my state, and I want to deliver communications to the eastern side of my state. I can create these Unicast RoIP links. If I employ a MU-law vocoder, 64 kilobits, I do the very simple math. I'm going to consume 128 kilobits of bandwidth for my network. Not really important. Networks nowadays, 128 kilobits is really not a lot until I start delving into satellite communications, where now I can become a little bit, I might want to become a little bit more stingy with my network. But what's really I wanted to illustrate here, Carol, is how we create these definitive Unicast links. Another example, again, employing Talkpaths as opposed to Unicast RoIP links. And so we're, again, starting to talk about Unity. And my illustration here is a little bit different. I still am supporting my to 4-wire devices in the form of donor radios. Also added other resources like a SIP VoIP telephony resource, maybe a push-to-talk of a cellular resource, maybe 4 outbound RTP or SIP streams to one of my existing voice logging recorders. So now we're starting to add more resources into a very small and capable gateway. And just for grins, Carol, I'm going to add a USB headset. In the front of that RSPZ2, there's a USB port which will support a wired USB headset or a wireless headset cradle, for instance. So, if you look at this illustration, I'm now able to support 9 separate resources from a single RSPZ2. And that's really because we're now set to a net configuration, which we call custom. And this allows me to create separate interoperable nets or domains where I can then move my tiles, which represent my resources, and allow those resources to share communications regardless of the protocol or that communication source. I like this custom net configuration, Carol, because it gives me lots of flexibility. And as you can see on the bottom, I can also create this unselect monitoring type communications. And so, this is an interesting illustration because this can't be done. I just wanted to illustrate something in terms of, let's say I take my 9 resources from the right and I want to stream that information over peer-to-peer RoIP links. I literally would need 9 RoIP links to facilitate that capability to share with other gateways, for instance, in my operational area. But this is not possible. So I'm just trying to make this illustration that, I really can't create 9 definitive RoIP links. It would be very difficult to manage these links, especially if I want to create on-the-fly routing of RoIP data. So if my mission changes and I want to route my SIP connection to another gateway, well, I'm going to have to log into this RSPZ2 or use software to manage these links. And so that becomes problematic, especially when we look into the future. Carol, as you know, we're starting to develop different gateways now. So the capacity of the gateways are starting to increase, and that could be problematic. So under Unity, what we can then create, as you mentioned earlier, is create a talk path. And I like defining a talk path as a trunk. And so if you look at what we have here illustrated in terms of what a talk path is, it allows us to consolidate all my remote communication sources into a single talk path and only consume, in this case, 64 kilobits by selecting a MuLA vocoder. And in fact, we can select and we can tailor the talk path depending on my network requirements, and create this fidelity versus bandwidth balance using these different codecs. All the way down to 6 kilobits, but if I'm, again, stingy with my network bandwidth, particularly if I'm using SATCOM, I might want to throttle that down to a GSM or a global system mobile codec, which only consumes 13 kilobits in each direction. So you have all these codecs available to you just to customize your system. And Carol, just as a reminder, I like showing this slide because it really kind of defines what gateway the RSPZ2 is capable of.
That slide is amazing, isn't it, Iggy? It is amazing how many different applications that the RSPZ2 can provide, and those applications just continue to grow as we add new firmware upgrades. That is an amazing slide. It shows almost everything that's there.
Yeah, thanks for reminding me about the upgrade. Really push our customers and our users of our products that are still lagging behind on the firmware updates of their RSPZ2s and controllers. You got to move out of that version 3 world and enter this really unique world of Unity. You can only achieve that by updating those gateways and controllers to version 4 or greater. And as you did mention earlier, Carol, you can download that firmware from our website free of charge. So really, you got to update so you get all these features, and particularly Unity. And again, like you mentioned, Carol, this RSPZ2 by itself, pretty formidable. But by introducing, as you mentioned, federating a number of RSPZ2s into a system that's under direct control of a controller, coordinated by a controller. Now you can see sort of the possibilities of creating these incredible large distributed wide area systems. So I like showing the screen because it really kind of defines one of our workhorses, and it's the RSPZ2. One of the other unique properties of Unity is creating what we call routing policies. And as you can see, I do have a number of RSPZ2s in this illustration. Sharing talk paths directly from gateway to gateway is dependent upon the capabilities of that network. Am I load balancing? Am I using the internet? Is this a private network? In a lot of cases, you're not going to be able to create this distributed routing policy, but in a lot of cases you can. So it all depends on the capabilities of your network. But this is a great way of desaturating the controller as opposed to delivering information to the controller. We can now distribute talk paths between the gateways themselves. So again, another benefit of Unity is creating the distributed routing policy. And so let's kind of define what we call the participants in Unity. And so on the left, we have the controller, and we call that the management device. It's all browser based. We log into the controller, the hardware. We log into the hardware, not servers. And it also contains that all important digital audio mixer, which allows us to circumvent the need for multicast. And so we're creating this sort of a pseudo multicast environment by implementing that digital audio mixer. On the right-hand side, we have our distributed system or systems. The reason we call the gateway a system, because it can actually operate on its own because of a network failure. That gateway acts as a system on its own. As you mentioned, we can add other devices into a system by unifying these devices using discovery mode, which we'll finish up with. Just kind of a review of all the resources that a distributed system can support. We define the participants, the management device on the left, which is really the controller, and then the distributed system or systems on the right, which can include, again, these remote gateways, which can still function on their own if isolated on the network. And we also include the ACU-Z1s in this example as well. And one of the important parts that you mentioned earlier, Carol, is what we call messaging. And messaging is really sort of a way that the hardware communicates with each other, all the participants and the management device to communicate with each other and create the system. And this also allows us to authenticate our distributed systems on the right and make sure that those distributed systems are part of the overall system. And we're going to look at this again in discovery mode shortly. And we can also use this device, again, as a configuration, control, and coordination platform. Again, it's that management hub. And what's important about messaging to understand it, it contains no audio. It's only data that allows, again, communications at a system level between all the hardware devices. Another part of Unity we've been talking about quite a bit are the talk paths. And this is an illustration of a talk path, but this talk path again is literally a trunk of radio, telephony, push-to-talk over cellular, JPS MCC console communications back to the management device itself.
You mentioned earlier, Iggy,
yes,
that you prefer to call the talkpaths Unity talkpaths trunks. I think that the trunk, after looking at this slide, better illustrates exactly what it does and how it works.
Yeah, if I think about it, that single talk path and that RSPZ2 in the upper right, it might be supporting 2 radios, might be supporting a couple SIP connections, maybe a couple push-to-talk over cellular talk groups. That's all contained in that single talk path, and it could be throttled down to 6 kilobits if you need be. So it's really Unity talkpaths equate to just efficiency, not only in terms of network bandwidth, but how I create connectivity. Makes our life simpler as operators. So this is really a good example of always using the hub. That's that routing policy. And again, if my network has that capability, I can support what we call fully distributed routing policy. Again, all depends on the network, but this helps us desaturate or unload some of the responsibilities from the management device. But just because I've created this distributed routing policy doesn't mean I'm cut off from my management device. Again, whether my routing policy is using the hub only or using distributed routing policies, sharing RoIP completely out at the edge between gateways, we're going to run not only messaging, but talkpaths at the same time. Remember, messaging doesn't contain audio. It only contains the language that distributed systems and management devices use, configure, control, and coordinate. It's all done under Unity. We're going to kind of finish up here, Carol. One of the really important aspects of Unity is discovery, and a lot of interesting words we like using, the federation of distributed systems, unification of distributed remote systems into a larger system or a wide area distributed system as a whole to facilitate the simple configuration or authentication or addition of remote gateways into a system, what we call discovery mode. You and I, Carol, had a discussion about making it simple for the end user to add to create or build a wide area system. So hopefully we kind of demystify that. It's actually incredibly simple. All right, so let's take a look at a couple screenshots from the management device on the left, which is my controller, and my distributed system on the right. Remember, my distributed system can comprise of up to 160 RSPZ2s and ACZ1s. And so each device has the user interface, also has a settings menu, and this is specific to the Unity settings of my management device on the left and my distributed systems on the right. The way we identify these devices, obviously by IP addresses, because they need to be located on the network, right? So we're identifying these devices by IP addresses. There's our messaging port. We take a specific port on the network, and this one happens to be 5999. You can change that based upon your network policies, and this is where we share messaging at a hardware level between these devices. Again, as you mentioned, Carol, all this is happening in the background. Thank goodness, because there's a lot of complexity taking place. So we're all going to share the same messaging port. Another identifying factor of each of these devices, whether you're a management device participant or a distributed system participant, is the local system ID. And as you can see, it looks like a MAC address, and it is. That's the serial number of each of these devices. You can change that if you like to any alphanumeric. This is really kind of the fingerprint of the device. So as you can see, the way we define these devices is IP address and the unique system ID. All right, so if I take my management device on the left, I can toggle on discovery mode. I can toggle it on and toggle it off. If I want to add a gateway into my existing system, I'm going to be in discovery mode because I want to authenticate these remote gateways or these distributed systems. When I'm done, as you mentioned, Carol, I can toggle discovery mode off. I can secure my system, basically close the door and create security and prevent unauthorized joining or unification into my system. So on the management device side, we're going to go into discovery mode. And now this allows us to begin adding gateways or distributed systems into my system. I can take my IP address of my management device and the local system ID of that management device, and I can share that information at the distributed system level, telling that distributed system where the parent controller is located on the network. Because we're in discovery mode, now we can authenticate that connection. And on the right, on the distributed system, I'm going to toggle on the enable switch, as we can see there. And we're going to wait for the connectivity to occur. And you can see on the bottom left of the user interface of the distributed system, we got a nice green indicator, meaning we've unified with the management device. And if I have a number of distributed systems, RSPZ2s, for instance, all I need to do is rinse and repeat, use the same IP address of my management device or my controller and its unique system ID, propagate that information into the distributed system, and I can then federate those gateways into the system. And it's simple as that. And once I'm done with that, as you mentioned, Carol, for security purposes, I'm going to toggle discovery mode off. And one of the features that we talked about in the RSPZ2, which is pretty very handy, and I use this quite often, is to back up the configuration. So let's say I'm going to build a system that, as an example, that might have 20 RSPZ2s. I can go ahead and federate one RSPZ2, back up its settings, and then I can mirror that setting into the remaining 19 RSPZ2s in my proposed system, change the IP addresses, obviously, of those devices, and I can then join a system immediately by using one known good configuration. So that's all in Unity. Upgrade your systems to version 4. We got a new version coming out in a couple of weeks. And Carol, you mentioned earlier, these aren't bug fixes. I mean, that's
It's true.
that's going to happen, but these are also related to features.
A lot of features, and they just
Yeah.
continue to grow. It's getting difficult for us to do a brief webcast with so many with these new firmware upgrades.
Yeah.
We find ourselves doing 2 or 3 or more webcasts just on one firmware upgrade, and then we try to keep them brief. But it's so feature rich, and that's just continuing to grow.
Yeah. I mean, yeah, I think we're providing really good content here. I know we always go over. It's very hard to control uh, our content here, but I think it's really good information. And again, like Carol, we're discussing um, earlier that we want to really make this simple and not scare the uh, the end user. It's very simple to build a system. Start small, and as you mentioned, start unifying and adding distributed systems. Going to discovery mode and discover those systems and start building your system. And you know, on our next webcast, we're going to dive deep into kind of the minutia of Unity, a lot of really cool features, and we're going to look at some. I'm going to use a live system that we have, and look at about a dozen different Unity features that are very unique. But one thing I want to do, Carol, is I want to finish up here. Discovery mode is great. Once I unify my distributed systems, I'm going to toggle that discovery mode off because I want to secure my system. So prevent any rogue gateways from entering my world. So I'm going to go ahead and turn that discovery mode off. And as you mentioned, Carol, once I federated those distributed systems into my overall system with my management device. They're persistently bonded to that system, right? I can break those at any time. I can actually manually add a gateway to my system, but this bond is very strong, and that's because of Unity. So one thing I wanted to mention, if we look at the screen here, and remember, one thing I want to really focus on is the IP address of my management device, as you can see here on the right, and also the unique system ID of my management device. Again, that's the footprint. This tells the distributed system where it needs to connect to. As long as that management device is discovery mode, I can federate, I can join, I can unify my remote assets into a system. But what's important that I want to really a good takeaway in terms of using this type of connection philosophy, sometimes we call that a client server association model, is that we can operate under really very adverse network environments. And this is an example of one of those. I don't want to call it adverse network environment because this is actually pretty common. I know you have a system that uses an LTE router. I have one. We have a lot of customers that use LTE routers, and in this case, they're implementing the internet. They can get fancy and use tunneling, for instance, but a lot of our customers are using LTE routers because they can now distribute that gateway in a tactical means. And so this is very common what we see here. But what's very important about Unity and that client server association model we use, which incorporates the IP address of the controller and the unique system ID of the controller, is that I can load balance. So if I had a LTE router that can support 2 SIM cards, 3, 4 SIM cards, there's probably LTE routers that can support many more than 4 SIM cards. That means I can be supported by different ISPs. That gives me diversity. But the problem with that is I'm going to be implementing a different public IP address. And that kind of complicates things, but not in our world because we're using this client server association. We tell the distributed system where to connect to in terms of the management device or the parent. So we don't really care what that IP address is, if it changes or not out at the edge. And Unity really is load balancing friendly. So another twist we can add to our tactical or our remote device is SATCOM. We see that a lot. There's lots of um, low Earth orbit and geostationary satellite applications out there, and there's a lot of it taking place with our end users and customers. Again, we're going to load balance if we're out in a remote location and we don't have LTE. We're going to load balance. We're going to start using that SATCOM connection. We now have a different static public IP address under Unity. We can load balance. So I just wanted to really kind of illustrate that and show you how simple it is to implement these remote devices because of Unity. And just one last thing I wanted to mention, we talked about routing policies. A routing policy that is fully distributed will probably not work very well in this type of situation because the network is so complex out at the edge. You can just simply use a always use hub routing policy where all RoIP information or talkpaths send their information to the management device. Then we leverage the digital audio mixer, create this pseudo multicast environment, and then we can redistribute radio telephony or push to talk over or JPS MCC console information, redistribute through the use of the digital audio mixer inside that management device. And we've went way over, Carol. Again, we say that every time, but I think we provided a lot of good information
Yeah,
for the
it's
customers.
difficult to keep it brief, as we mentioned earlier. And
Yeah.
JPS will attend an exhibit at the 2023 International EPCO Conference in Nashville in early August. In fact, it's going to be on August the 7th and 8th. If any of our attendees are attending APCO, please come by our booth, and we'd love to show you what Iggy has presented to you today. We're going to be in booth number 1310 at APCO, but please come by APCO. If you're at APCO, please come by the booth. And in our next webcast, we will talk about another new feature that Iggy mentioned. It's a result of the latest Z controller firmware upgrade. Iggy, would you mind giving us a brief interview in the next webcast?
Oh, yeah. Yeah, there's a lot of new things, and not only cosmetically. There's other features like creating folders or favorites. We're going to talk about the behavior of USB interfaces, and also we're going to talk about HTTPS, which has been pretty a big conversation internally. So we're now able to self-certify our devices, so we can implement these gateways on networks that have certain requirements in terms of network policies. But I'm going to talk about 10 or 12 different features under Unity and new build. So again, go to our website, download the your version of software, firmware, free of charge. If you have a really old um, distributed system, which is the RSPZ2, or your management device, which is the Z series controller, if you're running a very old build, you might have to do other things like a USB level update and then move your way up into 4.0. But update, it's free of charge as usual, and you're gonna see a lot of these great features.
Yeah, we'll make sure that everyone gets an invitation early prior to the next webcast, and uh, hope that everyone will hang around with us today. We'd like to answer your questions and hear your comments in our Q&A session today. So hang around with us, and again, we are very appreciative of your being with us today. And this presentation has been recorded, and it will be available very soon on the JPS website for anyone that was unable to attend today, or those that did attend would like to take a look at some of the specific things that Iggy talked about today. Excellent presentation, Iggy. Thank you. Thanks to each of you for joining us today. We really appreciate having you attend another JPS webcast. Thank you.
All right, take care, everybody. See you next time.